All right, first today we're going to start with this warm-up. There's 6 problems. So you are listing the transformations of these. Remember, this we've done before, okay? It's x squared, that's quadratic. Remember, you can put them in the calculator and look and see what the transformation is, but hopefully we've done this enough that you'll be able to just tell by looking at the equation what the transformations are. So go ahead and pause this for 3 minutes and do the transformations. Then we'll go over them after the 3 minutes has passed. Okay, this first problem is x squared minus 9. Remember, f of x is the original equation, and then g of x will be after the transformations. There's one transformation, it's minus 9. What does that minus 9 do? It makes it translate down 9. Okay, that's the only transformation from here. It's the only difference from this original equation. And remember, if I want to check it, I can do x squared and then x squared minus 9. Okay, the first equation in y1, the second equation in y2, and I can click graph. There's my original, my quadratic parent function. There's the second graph. It has moved down 9. Okay, so you can again check it. You're going to use the numbers from the problem. Number 2, we've got this 1/4 and the plus 5. Okay, the 1/4 is a vertical shrink by 1/4. Okay, that means it's going to be smushing it downward and it's going to get a lot fatter. Okay, make it a wider graph. And then the plus 5 makes it move up 5. Okay, so it's going to get fatter and move up 5. While the 3, on number 3, it only has this 1/2 here. Okay, it's another vertical shrink. It's not going to be as fat as a 1/4, but it will be fatter than the original, v shrink by 1/2. Okay, and then here they've got a 1/2, but it's a minus 1/2. Okay, so even though this is a fraction, and we're kind of used to seeing that with vertical shrinks and horizontal shrinks and stretches, it can still be like this. If it's added or subtracted onto the end, it's moving up or down that much. This one will be down 1/2 unit. Okay, 5 will be up 3. And 6 has 1, 2, 3 things. Remember that the negative and the 2 actually do 2 separate things. A negative outside or with no parentheses reflects in the x-axis. And the 2 itself would be a vertical stretch, okay, which means it's going to stretch it out and it's going to get skinnier. Okay, so vertical stretch by 2. And the third one is up 1. Okay, so this one, it'll reflect downward, it'll get skinnier and move up 1, up the y-axis 1 unit. Okay, so on this warm-up, go ahead and put your name on it and have the substitute will take it up and she can put it in the recycling bin. Okay, I just want to do a little bit of review before we started today's lesson so you know what's going on. Okay, go ahead, get out your notes. Okay, today's lesson is 5.4, and we're going to be graphing and transforming roots. Okay, this one's a pretty easy lesson. We've done everything that we're doing today. We've done before, only just not with roots. Okay, so the graph, you're going to see what the graph of a square root and a cube root. Those are going to be the 2 that we do them on today. You'll see what those graphs look like. That'll be like the one new thing you learn. All the rest is stuff that we've done before. Okay, and first thing we're going to do is put this box at the top of the page. And you can cut it out. You can pause it and cut it and glue it in if you want to right now, whatever it's going to be at the top of the page. And it's got 2 different graphs of functions. Okay, again, we're talking about square root functions and cube root functions today only. We're not going to go on to the higher level roots. Square root functions okay, r will be the square root of x. Okay, that would be the parent function for this one. And notice it starts at 0 and goes up and to the right, okay? While cube root starts at 0, goes up and to the right, and it goes down and to the left, okay? And if you put this in y equals, you'll see it gives you error for all the ones below 0, all the x's that are below 0. And that is because, remember, square root of a negative number is not real, okay? You can't graph it because it's not real. We talked about how it can be imaginary numbers, but we're just graphing the real numbers. So since square root x will have to be a positive number underneath there, since it's a square root or any even root, okay, this is a square root. Remember, if there's not a number there, it should be a 2. So that's why this one starts at 0 and goes up. Whereas cube roots, they can be negative or positive, right? It doesn't matter because that's something times itself 3 times. It can be positive or negative. Okay, so that's the main difference. Otherwise, they look a lot similar. Square root's also a little bit bigger, farther from the x-axis, whereas cube root's a little bit flatter, a little closer to the x-axis. And we're going to talk a lot about domain and range. Okay. On square root functions, it starts at 0. Remember, domain is x and range is y. So if we're looking at the x values, okay, just going left to right, okay, well, where does it start? It starts at 0, right? And there's nothing negative, so there's no negative numbers in the domain. And it's going to the right. What does this arrow mean? Remember, the arrow means infinity, okay? It's going on for